Hi, this is TheoryStation. I'm John Duggan, and this is the Rational Choice Modeling Program. The series we're in is called Individual and Social Choice, and this is the second installment in the series. We're going to call this More Properties of Preferences. And, well, as the title suggests, I'm just going to pick up from last time where we talked about three different properties of a preference relation: asymmetry, transitivity, and negative transitivity. And there we said that P, strict preference relation P, is a weak order as long as it is asymmetric and negatively transitive. Okay, those two properties are really just a formal way of isolating the preference relations that correspond to a ranking of alternatives. And we showed that those two properties together imply transitivity. Okay, so we could define many other properties of a preference relation, but instead I want to think about different kinds of comparisons a decision maker can make. So one, which we've been referring to, is whether an alternative is strictly better than another. Okay. Another comparison that you could make is to say that one alternative is at least as good as another, okay, which leaves open the possibility that they're equally good. So in that case, we're going to call that a weak preference instead of a strict. Okay, a weak preference leaves open the possibility that two alternatives are equally good, and actually those kinds of comparisons come up quite a bit in formal modeling, and so we are going to actually define another preference relation. It's derived from P, okay, and we're going to call that the weak preference relation that corresponds to P. All right, so given P, I'm going to define this weak preference relation. And we're going to have different notation for that. Okay, we don't want to use P again. And we're going to follow convention, and we're going to use an R to refer to that. Okay, so the weak preference relation, which we're going to denote by R, corresponding to P, is defined as follows. Okay, so this is a new thing. We're actually going to define a relation. Okay, to do that, I just need to tell you, given any two alternatives, how to identify whether there's a weak preference for one over the other. And the way I'm going to do that is I'm going to say for all alternatives x and y, we're going to define x to be weakly preferred to y if and only if it's not the case that y is better than x. Okay, so intuitively this means that if x is weakly preferred to y, that means that it's not below y in the ranking. So it's either at the same level as y or it's above. Okay. This statement that I've written here is called a logical biconditional, just as a way of introducing some logical notation. Not that we're going to use it that often. We can say if and only if. We can write that as this double an arrow going in both directions. So we can write that like so, x, r, y, if and only if not ypx. Okay. So this weak preference relation, this is a definition, so I'm going to underline defined terms like this, is defined like so. Okay, so if you have a strict preference relation, right, if I give you, let's go back to the one from our first example. I'm going to express this with a directed graph. Okay, so if this is our strict preference relation, our P, you can now use this definition to construct the corresponding weak preference relation. Okay, so how do we do that? This graph is going to have more arrows, arcs. Okay, let's just let's pick a couple cases here. Let's ask, and I'll do this in red. Is it the case for the preference relation that we have here, is it the case that A is weakly preferred to B? All right, well, let's go over to our strict preference relation and let's check. Is it true that B is preferred to A? No, it's not. There's no arc going from B to A there. It's not the case that B is strictly preferred to A. So according to our definition of weak preference, yes, A is weakly preferred to B. How about B and C? Is it the case that B is weakly preferred to C? Let's go back to our strict preference relation here and let's ask, is it true that C is preferred to B? Well, no, it's not. There's no arc there. C is not preferred to B, which means that B is weakly preferred to C. Okay. I guess I'll do one last one, and then I'm just going to fill it in. Let's check the case here. Is it true that C is weakly preferred to A? Well, let's go back to P here, to our strict preference relation, and let's ask, is it true that A is preferred to C? Well, it is actually. So that means that we can't put this arc here going from C to A. C is not weakly preferred to A. So, so those are three cases. If I just put in the rest of these arcs here to get an idea of what it looks like, it's going to have more arcs. Okay, and technically speaking, we actually need an arc going from A to itself and B to itself, C to itself, and so on. All right, so in red here, this is the weak preference relation that's generated by the strict preference. Okay. There's a lot of arcs in the graph, but the idea is really not, it's not hard. Okay. Let's do another derivative relation that that means that two alternatives are equally good. Okay, so given the strict preference relation P, we're going to define the indifference relation we're going to have separate notation for that. We're going to use this capital I for the indifference relation. Again, we're defining this. Again, I just need to give the conditions under which indifference holds. And formally speaking, we're going to say that given any two alternatives x and y, indifference holds between them if and only if it's not the case that x is preferred to y, and it's not the case that y is preferred to x. Okay. What that means is there's no preference between them. There's no strict preference between them in either direction. Okay. If neither is strictly preferred to the other, we're going to say that they're indifferent. They're equally good to the decision maker. Here I've used this logical notation. I'll give you another way of expressing this, though, now that we have the idea of weak preference. Instead of writing, it's not the case that x is strictly preferred to y, that's the same thing as y is at least as good as x. Instead of writing, it's not the case that y is strictly preferred to x, that's the same as saying x is at least as good as y. Okay? So, and that's just, substituting in our definition of weak preference. So this indifference relation is very intuitive. It means there's no strict preference going in either direction. An equivalent way of thinking about it, if you like, is that there's a weak preference going in both directions. Okay? Going back to our example, if this is our P, the indifference relation looks like what? Well, let's just take a pair of alternatives. How about B and C? Look at the strict preference relation and ask, is there a strict preference between those two alternatives in either direction? No, there's not. So that means that they're indifferent. Now, here, I should just point out, that means that this indifference between B and C holds, but so does the indifference between C and B. In fact, the indifference relation is what we call symmetric. It means it doesn't depend, the order of the two alternatives doesn't matter, okay? So, so we're actually going to put in two arcs here to denote, to represent the fact that indifference holds regardless of how we order the alternatives here. All right, as well, down here, indifference holds between D and E, and that's pretty much it, except, again, I'm not going to go into it, but just to be technically correct, we're going to say an alternative is indifferent to itself. That's what the indifference relation generated by P would look like, okay? So in terms of a ranking, it just means the alternatives are on the same level of the ranking, okay? These are super intuitive ideas, but, it gives us more notation to keep track of, and it also means that, well, we have more structure to play around with. So we can prove properties of the weak preference and indifference relations. Let me start off, though, sort of connecting all three of these. Let's look at just two alternatives. So let's say we have two alternatives. let's say A and B. So, and let's think about the preference between them. There's three possibilities. A can be strictly preferred to B. B could be strictly preferred to A. Or there could be no preference between them, right? I'm just realizing it probably would have been better to change the order of these things. Now let's just do this. Right? So there's three cases. Now I have B preferred to A first, A preferred to B, and then no preference. In the third case here, where there's no strict preference either way, we know that that means that they're indifferent, they're equally good. Okay. Obviously, this middle case here, A is strictly preferred to B. Notice that, okay, so in the first case, B is preferred to A, but it's not, B is not preferred to A in either of these, right? It's not the case that B is preferred to A in the middle and the right-hand case here. But that's the same thing as saying that A is weakly preferred to B. Okay, so the reason I'm writing this, it's really obvious when you look at it this way, but if A is strictly preferred to B, then it's weakly preferred. If the two alternatives are indifferent, then A is weakly preferred to B. Okay. On the other hand, if A is weakly preferred to B, then either it's strictly preferred or they're indifferent. Okay. What I'm getting at is the following proposition, and I'm not going to prove this one in a formal way because I think the idea is clear enough. The proposition is that for any two alternatives, X and Y, X is weakly preferred to Y if and only if either it's strictly preferred to Y or the two are equally good. Okay, I'm writing that in logical notation, but it really is just formalizing the picture above. Okay, so that's kind of connecting all three of these relations. We can deduce different properties of these relations. I think that, well, let me just give a couple. Okay. The first is that if P is a weak order, and that means that it's asymmetric and negatively transitive, then R is transitive. So, you know, if you think about it in terms of ranking, it should be pretty clear. If X is at least as high as Y in the ranking and Y is at least as high as Z, then X must be at least as high as Z. I think just to save time, I won't go into the details of that proof. But let's also point out that if P is a weak order, then indifference is also transitive. And this is actually pretty easy. So let's assume P is a weak order. And from the previous proposition up here, we know that R is transitive. Now I want to prove that I is transitive, the indifference is transitive. So I'm going to reach into this bag and I'm going to pull out three alternatives. Let's call them A, B, and C. And I want to show that if it happens that A is indifferent to B and B is indifferent to C, I want to show that if that happens to be the case, the A and C are equally good. Okay. All right. Well, since A and B are equally good, remember that an alternative is weakly preferred to another if and only if either it's strictly preferred or indifferent. Here's a case where these two alternatives are indifferent. So that means that, in particular, A is weakly preferred to B. Since B and C are indifferent, in particular, that means that B is at least as good as C. All right. So now we have these two weak preferences, which are implied by the indifferences. A is at least as good as B. B is at least as good as C. By transitivity, that means that that A is at least as good as C. All right, now you can check for yourself. You can do this argument in the other direction. Okay, that is, C is at least as good as B, B is at least as good as A, and you can apply transitivity again to get C weakly preferred to A. And I'm going to skip that here and just write, by a similar argument, C is weakly preferred to A. All right, well now we've shown that A is weakly preferred to C and C is weakly preferred to A. Remember how we defined indifference. We said indifference holds whenever you don't have a strict preference in either direction, but then that's the same as saying a weak preference holds in both directions. Well, here we have a weak preference in both directions. A is weakly preferred to C, C is weakly preferred to A. That means that they're indifferent. Okay, so we took any three alternatives and we just showed that if we have this indifference, if A is indifferent to B and B is indifferent to C, then A must be indifferent to C. That is transitivity of indifference, okay? And that holds for any weak order. All right, so we've connected these relations and we've seen how properties of strict preference imply properties of weak preference and indifference. There's way more we could do, but I think that's enough for now. In the next installment, I want to talk a little bit about choice, and we'll get to utility as well. I'll see you there.